Hello friends, thank you for watching this video. I am Mohamad and today we're going to be discussing unit tests with .NET 6. We're going to start very simple by adding a unit test library to our console application and then try to create some tests to test the application functionality. Once that is done, we're going to jump into something which is more a bit complicated, which is going to require dependency injection, and then we're going to see how we can actually utilize the MOQ library in order for us to get there. If you like this video, please like, share and subscribe. It will really help the channel. So let's jump into it. We're going to start by discussing unit tests with xUnit and MOQ in ASP.NET Core 6. So let's see what's on the agenda for today. First, we're going to be discussing what is a unit test and then why do we need it. Then we're going to be jumping deep into the frameworks of unit tests. Once that is done, we're going to be discussing how can we think about unit tests and how can we approach them. Then we're going to be discussing some of the ingredients that we're going to be needing in order for us to do the unit test, and then we're going to be jumping into the coding. So what is a unit test? A unit test we can think about as the smallest piece of code that we currently have that we can test. We can think about them as the functions that we currently have. So for example, let's say we have a controller and inside that controller we are adding, editing, deleting and viewing all of the employees. Every single piece of this controller is a function and every single function can be tested separately and every single function is completely isolated from the other one. So for example, once we are calling the view all, that's function is going to run in a complete isolation, so we can test that by itself. If let's say we're trying to update a user or an employee, that's also going to run complete isolation. If we're trying to create or add a new employee, that's going to be run in isolation. So a unit test basically are functions or a separate piece of code that only run together in complete isolation of the rest of the code, and basically within this we can actually execute some testing against this isolated piece of code in order for us to get the result. So in summary, that's what a unit test is. We're trying to test a single unit of piece of code or a single piece of isolated code. So why do we use unit tests? First thing is save time. By actually writing a lot of other automated tests, we're actually saving a lot of time by doing all of the manual tests that the usual QA needs to do. So by having all of these tests written once and make sure that they are run in automation, we are actually saving a lot of human hours in order for us to do all of those manual tests, which usually the QA people do. So first thing is the automation that we can actually get by saving time. Second, actually it's the opposite. By running all of these tests, we're saving a lot of time. Second of all is when it comes to automating testing, we can have a lot of much more detailed scenarios and much more in specific scenarios that we want to test. Specifically if we're dealing with such a big enterprise solutions, or for example with a lot of complex financial data, a lot of these testing needs to be done up to the point and up to the digit that we are trying to accomplish with these functionalities. So that's why unit tests are much more faster for running these tests, because basically once we automate them and we can automate these advanced testing scenarios, we can get the results ASAP as soon as these tests runs. As well, on top of all of that, if in case anything directly breaks when we change any part of our code, we can directly recognize it when we're trying to run unit tests. From the developer point of view, so for example, let's say a developer changed something on their machine related to a specific piece of code and they run the test for it and it fails, they can actually directly recognize where did it fail, how can they fix it, and actually investigate the issue. If we're going to wait for manual testing, so let's say for example a developer does any of the work and for example it passed his own testing or her own testing, once it actually goes to QA and then the QA goes through the testing process from A to Z and they have to do everything 1, 2, 3, 4 in order for them to get the specific case, that's where you can see that the time is going to be consumed in order for us to get to that point. While on the other hand, if there was unit tests from the get-go where it's actually covered all of the detailed scenario that we currently have, we would have saved all of this roundabout trip and the developer will be able to fix that scenario right there and there. So that's the first point, saving time. The second point is automation. As we have said before, when it comes to saving time, automation is a very powerful tool. So for example, if we have like thousands upon thousands of tests covering those details or this enterprise application that we currently have, running those automation, we can either run overnight, we can either running, for example, on a scheduled task, we can either running on demand. All of this automation is really powerful for us, because basically once those automation are running in the background, the developer can do any other work that they need to be doing in order for them to move forward with the job or for the task that they are trying to do. And whilst those automated testing are running in the background, if there's any issues, then developer will be actually notified. So we can see here that the feedback loop, which is really important that automation and unit tests provide us, is really good for the life cycle of the product as well as the quality of the code that the developer is actually producing. The third point is efficiency, and this is really important because in order for us to apply unit testing, our code needs to be of a certain standards. For example, it needs to have all of the solid principle already integrated inside that code. So we are actually allowed to have dependency injection, which will allow us to mock certain services, so on and so forth. So that by itself, it will give us a very structured and a very rigid code, source code that we can actually utilize and expand upon. So all of that unit testing is going to be able to provide us that out of the box, because if we want to implement unit tests, we need to implement a solid coding principles in order for us to actually test it in a unit test way. As well, with unit tests, we are making sure that we are covering all of the potential troublesome scenarios, specifically when dealing, for example, with financial data, with a difficult transaction, high speed or high throughput scenarios. All of those unit tests will be able to actually give us the information that we need and making sure that we are covering all of the aspects. Of course, there is no 100% certainty that we're going to be able to get this product bug free, but at least unit testing will be able to give us at least 99.999% that we are almost getting there. There's always going to be some certain scenario that we might not think of. We only might discover them later on down the road when the application goes into production, which is not recommended at all. But at least once we are covering all of these, we are able to at least know from the beginning if something going wrong, where is it, how can we fix it, and how fast we can put a fix in order for us to get it up and running. The fourth point of why do we need unit tests is documentation. Because basically once we are trying to write unit tests, in a way we are actually documenting the functionality of our application. Because if we think about it, when we're writing unit tests, we're not just writing a test making sure that the input is valid, or we're making sure that the outcome is of a certain format. That's not the case. When we're trying to build a unit test, what we're trying to do is we're actually trying to build a client of that application. For example, let's say we are trying to write a unit test for our API. The unit tests are basically the first client that's going to be consuming that API. And basically, once we think about it that way, we are actually documenting all of the processes and all of the functionality that this API has. And in a way, we can actually have a certain type of documentation that will allow us to understand what this API is doing and what are the critical points of this API that we need to pay really attention to. The fifth point here is going to be code quality, because if we think about it, if we are already applying those solid principles, we are applying proper dependency injection, we are applying unit tests, our code quality is going to be much more higher than if we're not doing that. And that means that maintenance of the code is going to be way more easier, expandability of the code is going to be way more easier, trying to add more functionality is going to be way more easier, because we already have a strong code base and have a strong source code that we can actually utilize on the long run. The last point is it's going to make our code reliable. Why? Because if we have those unit tests running in an automated way, for example, every night, making sure that we are getting 100% of our tests correct, there's no single failure. It makes us know that it will allow us to know that all of the changes that we have introduced to the source code did not affect the current functionality. And it means that when any consumer is trying to consume our application, they're going to have the same results as before. And that should give us a bit of a peace of mind that our code is reliable and the source code that we are putting out on the application that we are actually giving it to the public is actually executing as it should be. And in case any of our changes has affected the existing behavior of our application, the unit test will fail. Because that we can see here the direct interconnectivity between our application, the source code we introduce, and the unit test. So it makes us protected from from failure or potential failure when it goes to production. When it comes to frameworks, inside ASP.NET Core, there is mainly 3 frameworks that we can actually utilize. The first one is MS-Test, which is the oldest framework that currently exists. MS-Test is very reliable, but it's also very slow. That's why I don't really recommend utilizing MS-Test. The second one is xUnit, and xUnit has a lot of features baked into it. It's much more faster than MS-Test, as well it's much more stable than MS-Test. And the other one, and the last one, is going to be xUnit. Again, xUnit is very fast, it has a lot of functionality, and is very reliable. For this demo today, we're going to be focusing on xUnit. So, how should we think about testing? Well, in essence, when it comes to thinking about testing, we need to think about it as a consumer of the API. So let's say, for example, we have an application that takes, for example, registration from a form, and we have an API endpoint that we want to test. So in order for us to think about that, we can, for example, create tests if the valid of a string is equal to a certain length. If, for example, these are all valid tests, or for example, if a mobile number of a certain length. That's all the valuable tests. But when it comes to actually thinking about it, we need to think about it in a way that how a consumer will actually utilize it, of how our API consumer will gonna be consuming actually this API. We need to think about it of a way that we wanna utilize this API. We don't want to go to the nitty-gritty of adding or writing tests for every single aspect of our piece of code or isolated piece of code that we have. We need to find the right combination of time as well as code coverage, and finding this right balance and finding this right equivalence of basically time and code coverage is going to be the key structure. Because if you want to write tests, you can spend weeks upon weeks upon weeks on writing unit tests for a certain controller, but that's not what we want. We want basically for us to cover the main aspects, or gonna be the most challenging aspect of our controllers, the most complicated parts that, for example, certain client-side validation will not be able to do, certain API-side validation will not be able to do. These stuff that we need to actually write unit tests for, the complicated business scenarios and the complicated, for example, calculations that we currently have that we need to do the unit test for. It's not gonna be only about writing like a validation about length string or a valid phone number or valid email. Again, those are actually valid unit tests, but it's going to be up to the developer and up to the business needs of the level of the code coverage that you want the test to do. As well, on top of all of that, you need to think about it in a way of how you want to utilize it as a consumer. How are you trying to approach that API? How are you trying to actually utilize that API? Not actually going line by line inside our controller or outside our action, our function, to write unit tests for every single line. You can do that, but again, it's all about the balance between code coverage as well as the time that we want to actually utilize in order for us to write the unit test. So what are the ingredients that we're going to be needing? First, we need to have Visual Studio Code, because that's going to be our code editor. As well, we're going to be needing the .NET 6 SDK. You can find the links in the description down below or on the screen right now. So, the first thing that we need to do is we need to make sure that the .NET SDK is installed successfully. In order for us to do that, what we need to do is we need to run the .NET-version command in order for us to check the command, the SDK version on our machine. So how do we do that? Inside our terminal, we write .NET-version, and we should see here the version of our .NET SDK, and in this case I have version 6.0.101, which is the latest version of the .NET 6 SDK by the time of this recording. So once we have done that, the next step for us is actually we need to create our application, and we're going to start from there. So here what we're going to be doing is we're going to be creating a console application, and we're going to be adding all of the stuff to that console application. So it's going to be .NET new console. We'll give it a name, and we can call it, for example, let's call it testing app, and we'll create this console application. Perfect. So now let's open our application in Visual Studio Code. Now that we have opened our application in Visual Studio Code, the first thing we need to do is open our command line. So go to terminal, new terminal, and we'll have our terminal here. So the first thing we need to do is we need to go to our application, and then we're gonna run .NET build to make sure that the application is building as it should be. Once that is done, the next step is we need to install some NuGet packages, and these NuGet packages are basically the unit test packages that we're gonna be utilizing. So the first NuGet package is gonna be the Microsoft Testing SDK. So it's gonna be .NET add package Microsoft .NET .test .sdk. That's the first one, and this should take a few seconds to be completed. Perfect. The second one is going to be xUnit, so it's going to be .NET add package xUnit. Also, this is going to take a few seconds. Perfect. The third one is going to be .NET. Let's remove this. It's going to be .NET add package xUnit .runner .visual studio. Also another few seconds that needs to, okay, perfect. And the last one is going to be .NET add package coverlet.collector. Perfect. So once these packages has been installed, what we can do is we can go to our CS Proj file and we can make sure that everything is installed there. So first we have the .NET SDK, xUnit, as well as the coverlet collector. Great. Let's build our application to make sure it's building successfully. So .NET build. Great. So now that we have actually created our application and we have added all of the NuGet packages that we need to do, the next step for us is we're going to be creating a small user management functionality. It's going to be very basic, something that we can actually write unit test against. So inside our application here, we're going to create a new folder and we're just going to call it functionality. Any random name will do, but for now we're just calling it like that. We're going to create a new class, and inside this new class we're going to call it user functionality. Or actually we can call it user management, because we're trying to implement a user management. Manage. Okay, great. So once we have created this file, the first thing we need to do is add a namespace. And this is because this is .NET 6, we can just add a semicolon at the end of it. So it's gonna be, what's the name of the application that we said? It's gonna be, okay. So this is the first wrong thing that we did. We added in the wrong folder. So let's delete this and let's do that again. So this needs to be inside our testing app. So here, we'll add a new folder, we'll call it functionality. And inside this functionality folder, we create a new class and we'll call this class user management. And the first thing we need to do with that is just like take the standard of .NET 6 and make it the way that .NET 6 likes it, which is like this. Once we have done that, right now what we need to do is, again, because we are utilizing .NET 6 and actually after .NET C#9, C#10, sorry, because we are using C#10, where the functionality that we're going to be using was introduced in C#9, which is records. It will make it much more easier for us than creating classes. So it's going to be public record. We're going to call this record user, and basically it's going to have a string of a first name and a string of a last name. The next step is we're going to be actually adding properties to it, which is going to be int of type ID, and then we're going to be adding the date time. So prop date time, I'm going to call it created date, and we're going to give it a default value of date time .utc now. And then once that is done, we're going to add the phone number, and the last one is going to be the verified email. So property, it's going to be boolean, and it's going to be verified verified email, and we're gonna give it the default value of false, just to be on the safe side. Okay, so that's the record that we're having. The next step is we're gonna actually start implementing our user management class. So the first thing first is we need to basically, because this is currently right now is going to be a console application, we don't want to go into the entire process of actually creating a database and actually try to create a DB contacts, and we're going to actually connect it and have all of that, so on and so forth. So for the sake of this demo right now, we're going to be creating an in-memory database, and that in-memory database is going to contain a list of users, and we're going to take it from there. So again, this is going to be an in-memory database. For the rest of the video, everything we're going to be doing is going to be in memory. In the next one, we're going to actually see how we can connect to a database and create the unit test from there. So how can we create an in-memory database? It's going to be very easy. So we're going to put private read only. We're going to make a list of users. We're going to call them users, and basically they're going to be, again, all of these functionality and the way we identify is part of C#, then we can actually directly utilize them. So this replace equal the new list of user parentheses. Great. Once we have done that, the next step for us is we need to create, because it's an in-memory database, we need to create an counter for the ID, so it will automatically increment, so in case we are adding more users. So for that, we're gonna have a private int, we're just gonna call it ID counter, simple as that. Gonna give it an ID 1 to start with, and then we can add another to it. So once we have done that, now we're gonna add a couple of methods, and these methods basically they're gonna be able to return to us all of the information that we need from this class. So first one is gonna be public, and we're gonna allow us to get all of the list of users that currently exist. So it's gonna be public I enumerable of type user, and basically we're gonna call it all users, and basically it's gonna give us the list, as simple as that. So that's the first thing. The second thing is gonna be adding users. So public void add, it's gonna take a user, and basically what it's gonna be doing is gonna be adding it to the list. So it's gonna be underscore users dot add user. And basically what we need to do is we need to automatically, manually, increment the ID for it. So the way we do that is we're gonna put with, actually here, with ID equal ID counter plus plus. So that's what's gonna be doing is it's gonna take the user that we have, it's gonna take the first name, last name, and then for the ID we're gonna be automatically auto-incrementing it, and the rest, the phone number is gonna be empty, date time is gonna be automatically set, and verified email is gonna be automatically set. Great. Once we have done that, we're gonna add another functionality which is gonna be update phone number, and basically what we're gonna take is public void update phone user, just gonna take the same user and we can utilize from there. And all we're gonna be doing right now is we're gonna be we're gonna take this in-memory database, look for that user with the same ID, and then just update the phone number. So it's gonna be var db user, for now we're gonna call it, underscore users dot first, and we're gonna pass the condition where x.id equal user.id, and then once we have that, we're gonna put db user.phone equal user.phone, as simple as that. So once we have done that, we're gonna do the same thing for the email. It's gonna be same logic, but instead of update phone, it's gonna be verify email. And actually, instead of passing the ID, we can make it as an integer here. I will put here user ID, and we can pass this like this, and verified email is gonna be true. Simpler like that. And after we do all of that, I think that's more than enough for a demo functionality for our application right now. So let's save this. And once we save this, what we're going to be doing right now is we need to actually start unit testing. So how are we going to be starting unit testing? There's a couple of ways we can do that. The first one is we can actually write our unit test inside our main console application and try to add them from there. That's a good approach, but if we're gonna try to like stick to a certain standard, it's better to always create a separate console application that's actually gonna be testing, a separate class library application that's gonna be testing our console application. So that's what we're gonna be doing right now. We're gonna actually create a console class library, and that class library, the main job for it is gonna be actually to test our console application. So let's do this right now. So first thing first, let's check where we are here. So we are inside the PWD. Inside our testing app, we're gonna go one folder behind, and here we're gonna actually create the new application. So it's gonna be .NET new, and because we are testing, we cannot just create any normal class library. We need to create an xUnit library. So it's gonna be xUnit -n. And basically what we can do here, we can put testing, what did we call the application? Testing app .test. It's always to have the .test added to it in order for us to know it's a test. So once we create this, just take a few seconds, and we can see here that the application has been created for us. So let's open it here, and we can see our application here. Very simple, very easy. Here we have our first test. We don't need it, let's delete it, and then we create our own test. Delete, yes, thank you very much. So once we have deleted it, the first thing we need to do is we need to add reference between this new class library and our application. How do we do that? We just utilize the .NET add. So .NET add testing app .cs approach reference to testing app .test, testing app .test, and then we click on enter. We can see I think it's going to be the opposite. Oh yeah, it's going to be the opposite. Apologies for this. Yeah, this shouldn't be here, it's the opposite way. So let's delete this, save it. Actually, that I think about it, we have added this here in case we wanted to add, that was the original plan, if we want to add the same test inside our main console application, but we don't want this right now, so all of this we don't really need at this moment. So we can remove them. Yeah, let's remove them. And let's add the reference that we wanted to add. So we're gonna put, let's remove this. So it's not gonna be test. It's not gonna be test. Here it's gonna be test. .test. And here it's gonna be .test. And let's run it. Reference add completed. So if we open this, we should see a reference to it. Perfect, exactly one that I wanted. Great. So once we have added those, what we're gonna do is we're gonna add a new class. And this class, we're gonna call it user management testing, based on the class that we wanna test, user management testing. Great. So once we have done that, the next step for us is we wanna actually start writing our test. And the way that we said before is when we wanna actually test our code and we wanna actually execute test, we want to think about it when we're writing our tests as if we are a consumer of that functionality or a consumer of that API, of that endpoint, so on and so forth. So we want to think about it of a way that we are actually consuming it. So that's what we're going to be doing right now. So the first thing we want to do is we're going to actually first add the test. So how do we do that? Well, first we need to decorate any method that we create by this attribute fact. So when we add a fact, mean we are telling it that this is going to be like the first unit test that we want to run, or that's the unit, not the first, that's the unit test that we want to run. After that, it's going to be a normal function, public void, and then we're going to give it a name. So because we're going to add first the functionality inside user management here, the add functionality, that's the first thing we want to add, a test. So we're going to put void, and we're going to put add, and we're gonna call it add user or create user. So that's the first one we wanna add. We're gonna test. We're giving it any random name, but once we see that name, we need to understand what's going on, and that's part of the documentation that we spoke of. So once we have done that, we can actually write now. First, let us add those references here using xUnit. And now we need to actually write our test. So how do we write, or how do we start writing our test? So writing a test is consumed of 3 parts. First is going to be a range. Then act. Then assert. So what does arrange, act, assert mean? So arrange means that we're going to actually point it out to the exact function or method that we want to test. That's the first thing. So then act is actually we're going to actually execute what we want. So let's say we want to add a user, we want to execute adding a user. And then once we execute, we're going to get a response. And then we're going to utilize that response in the assert phase, which is the last one, which is basically we're going to compare what we currently have with the expected results. And this comparison is actually what's going to make the test succeed or fail. So let's do that again. So as we can see here, we have 3 sections. We have the arrange, which we're basically setting up our test to connect to the right part of the code that we want to test. Second is we're going to execute that code in order for us to get a response. And then third is going to be the assertion, which is going to be actually combining, or not combining, we're going to be comparing the outcome of the execution with the expected outcome that we want to, that is the actual outcome that needs to be out. And once we compare these two, if they are equal, for example, or they are the same number, so on and so forth, that has passed. If there's any difference between them, it's gonna fail. So let's do this right now. So the first thing first, because basically what we did here is gonna be a simple class, we can actually just initialize it, and that's what we're gonna be doing right now. So it's gonna be var user management equal new user management without the test. And we're gonna have to fix the references, so let's do this right now. Okay, great. So once we have done that, the next step for us is we actually wanna actually add a user, which is the action that we wanna do. So inside our act, we're gonna put user management dot add, and we're gonna add a new record inside of it, and basically we're gonna put the new, and we're gonna pass the first name, it's gonna be Mohamad, and we're gonna pass the last name, and basically we are passing the record information that we have. As simple as that. So once we have done that, the next step for us is we need to actually assert. It means that we need to actually test if that addition has been successful, and the information that we are actually added is success or not. Again, this is all an in-memory database, so it should be fairly easy for us to do. So first we're gonna put var, we're gonna get the result that we saved user, we're gonna say equal, we're gonna check by assert dot single, and we're gonna put user management dot all user. So what does that mean? It means that because right now it's an in-memory database and it's empty, so we only have one, and we are asserting that we have only one single user, or basically we're getting the first one inside of that. So once we have done that, the first thing we need to do is assert dot not null, or actually not null, let's start with that, and we're gonna put saved user. So basically what we are here checking that the user management list is not empty. So that's the first thing. The second test that we want to do is assert dot equal. What does that mean? We want to actually make sure that the value that we have saved inside the save user is actually the one that we have currently saved. So first we're gonna say what is the expected value. So my first name needs to be Mohamad, and the last name needs to be saved user dot first name. So we need to make sure that these two match. Then we're gonna put assert dot equal as well for my last name. So it's gonna be Lawand, and it's gonna be saved user dot last name. So now that we have asserted basically that the actual value is not null, and the actual information that we have saved, first name and last name, are actually equal, which is great. Then what we're going to be doing is we need to make sure that the email validation is false, because this email validation has been added by our record directly. So let's do this now. So we're gonna be assert dot, and as we can see here, we have a lot of options that we can actually utilize to assert certain information, a lot of options, and this is gonna make our life way more easier. So right now, because we're checking a boolean, so what we can do is we can just put false, and we need to make sure to pass the right value. So saved user dot verified email. So because this is out of the box, needs to be false, so this should pass here. So let's do a quick recap. We have created our class, and then the first thing we did inside this class, we added the decorator fact, which means it's going to be a unit test, and then we started creating our function, which is the unit test itself, and it's separated into three. We said the arrange, the act, the assert. The arrange is we're going to be specifying the piece of code that we want to test. Act is actually executing that code, and basically assert, we need to actually verify the outcome of that code, make sure it actually give us the expected outcome. So now, how do we test it, you might think to yourself. So the first thing we need to do is we need to navigate to that library. So as we said, it's testing app.test. And once we navigate, .NET made it really easy for us, and we have basically a command from the command line that we can actually execute in order for us to get the answer that we want. And that command is going to be .NET test, as simple as that. So inside that terminal, what we need to do is we need to write .NET test. We need to wait for it a few seconds for it to start to build the application first, and then it's gonna start running, and we can see here application has built, and then we got the result that we wanted. And we can see here that we have the past, which is great, and basically it gives us a quick summary of our tests. So we have 0 test failed, which is perfect. We have 1 test which is passed, which is the only test that we have, and then we have 0 test skipped, and we have basically the duration amount it took for us to execute this. Great. So the second function that we're going to be adding right now is for us to check the update mobile functionality, if it actually works or not. So how are we going to be doing that? Again, if we want to write a unit test, the first thing we need to do is write a fact. So we can say it's a unit test, then we put a public, and then we're going to put a void because it's not returning anything, and we're going to put here update, and we're going to put update what? Basically we're going to put update mobile number. It's not going to take anything, and basically we're going to have to do the same 3 pieces again. So as we said before, the first one is going to be arrange, then it's going to be act, and then finally it's going to be assert. The triple A's. Okay, so we can utilize the same thing as here. So let's copy this and this, because basically it's the same information that we currently have. So let's copy these. Okay, great. So once we have put the arrange and the act, the next step for us is to actually we need to build on the act and actually update our mobile number. So we're gonna put user management, or actually, yeah, let's get first the user management, the user. So we're gonna put var first user equal user management dot all users dot to list dot first. Let's just do this dot first, and let us add system.link. I think yes, system.link, and that should work perfect. And now once we have done that, we're gonna update it. So first user dot mobile number phone number, yeah, dot phone. We're just gonna put it, let's give it, for example, +44, this number, for example, and that should be it. And once we have done that, what we need to do is we need to update the phone. So we're gonna put user management dot update phone, and we're gonna pass first user. So basically what we did here is we added a user, and then we got the user, we have updated their phone number, and then we sent it back to the method that we currently have called update user for us to update the phone. Now we need to assert. Now the fun part starts. So how are we going to assert? So first thing first, we need to get that same thing as we here. We need to get the first user. So let's copy this and we'll put it here. So var saved user, assert single, and then we're getting that user. And first of all, we need to check assert dot not null. So we want to make sure that it's not empty, and we're going to put saved user, And then once we have done that, we want to check the value, so we can put assert dot equal, and then we're gonna pass the mobile number that we have added. Let's copy this, and let's here pass the mobile number, which is gonna be saved user dot phone, and that should be it. Okay, great. So let's save this, and now let's run our tests. And now we should see 2 of 2. Perfect. So we have green, which is passed, and we have 2 of 2, which means that all of our test has passed. Excuse me. So now that means that our first part of the testing has been completed, and basically right now we have covered a simple methods of actually writing some functionality, a very basic functionality, creating an xUnit application or a console library, connecting it to the main console application by the reference that we have added, and then we have written 2 tests, and we have introduced the 3 part, which is going to be, first of all, it's going to be arrange, act, and assert. As we said before, arrange is actually just arranging the data. Act is actually implementing the act that we want to do, adding, updating, deleting, so on and so forth, and assert, making sure that the outcome of the act is the expected outcome that we have. So that's the first part. The second part right now that we're going to be delving into, which is going to be more of how we can actually utilize unit tests with dependency injection and basically with interfaces as a first step. Okay, so let's get into it right now. Now that we have covered the first part, now we're starting to start with the second part with the interface injection, and basically in this part we're going to be utilizing the MOQ library. But first we're going to try to do everything manually and see, and then we're going to introduce the MOQ library and see how that library is able to help us, first by saving a lot of time and reducing a lot of the error-prone code that we might have introduced in order for us to write unit tests. Okay, so let's start. First thing first, what we need to do is we need to add a new functionality inside our functionality folder. So inside the functionality folder, right click, new class, and this new class, basically what we're going to call it is shopping cart. And basically the functionality that we're trying to create here is we're going to try to make a shopping cart, basically adding stuff to it, removing stuff to it, something like that. Very simple implementation. The main thought behind this is we're gonna try to do some constructor injection to our shopping cart, and then we're gonna see how we can actually mimic constructor injection inside our unit test. So we're gonna call this shopping cart, and if we open our functionality we should see it's not there. Let's try again, the new class, shopping cart again. Let's try, it's not adding for some reason. Let us add a new file. We'll call it shoppingcart.cs. And basically it's going to be similar to here. So let's take the same namespace and let's put it here. And then what we can do is we can just create a public class and we'll call it shopping cart. And we'll take it from there. So now we have basically a class called shopping cart inside our functionality folder. The first thing first is we're gonna actually try to create an interface, and that interface is gonna try to represent a library. And from there on, once we have that interface and we have that library, we're gonna inject that interface. We're gonna create an interface which is gonna represent a database. Or what I mean by database here, it can be a database library, it can be a direct DB connection, it could be a direct context for a database, anything we want. For now, we're just trying to mimic a database. So we're going to create that interface first, which basically represents a DB context or a database for us. And then we're going to inject this interface inside the constructor of our shopping cart to implement that we are trying to do a injection of an interface for us to save stuff to our database. This is all for demo purposes. Okay, so first thing first is let us create this interface, and basically it's gonna be public interface, and we're gonna call it DB service, just to try to mimic a database service. And basically inside this IDB service we're gonna have 2 methods, both of them save item to shopping cart, and we're gonna pass the product. We want to create a product. We'll create this product right now. We'll call it prod. And the second one is as well bool remove item from shopping cart. Simple as that. And also all we're gonna pass is the integer, which is gonna be our product ID. Simple as that. So now let's create a product. Let's do that before that. And basically we're gonna do the same thing as we did before for a product, which is basically gonna creating a record. So public record product, and we're gonna pass int, which is gonna be an ID, string, which is gonna be a name, and lastly we're gonna pass the price. Any random information right now, to be honest. So that's what we're gonna have. We're gonna have didn't put the price. So we're gonna have a record, which is gonna be basically an ID, a name, and a price. We're gonna utilize this inside our interface, which is gonna represent the database, which has a couple of methods: save item to shopping cart and remove item to shopping cart. And lastly, we're gonna have the shopping cart functionality, which is gonna be utilizing the IDB service interface in order for it to inject this functionality inside the class. So inside our shopping cart here, let's do this. What we're gonna be doing is we're gonna be initializing the IDB service. And we're gonna just call it underscore DB service, and let's make it private. Make it private, just to be on the safe side. And then once we do that, we're gonna create a constructor. And basically what we're gonna do is we're gonna pass this IDB service to the constructor, and then once we have done that, service. Once we have done that, we're just gonna initialize it, so DB service equal DB service. Simple as that. So now what we have here, we have a class which has an interface inside of it, and it utilizes constructor injection in order for us to initialize that interface. Perfect. So once we have done that, let us now try to create some functionality for the shopping cart. But before we do that, I just want to mention something. So if let's say we are in a ASP.NET application, and I have this, for example, this interface I want to execute. Please remember that this, if you want to initialize it there, it has to be, for example, services. Just say, for example, inside the constructor could be services dot add singleton, for example, and there inside of it we put, for example, the IDB service with, for example, DB service, and that's how we initialize it, for example, inside an ASP.NET application, for example. So we're trying to mimic that type of injection, this type of dependency injection, what we're trying to mimic right now in order for us to do a unit test. So I just wanted to clarify that out. So once we have done that, right now it's on for us to add some functionality, and the functionality that we're going to be adding is, as it says here, simple shopping cart functionality. So the first one that we're going to be adding is basically adding stuff to the cart. So public bool add product, and it's going to take a product. And we need to make sure that the product is not null. Let's do it like that. And first of all, we're gonna check if product equal null. We're gonna return false. Return false. Then we're gonna check if the product dot ID is equal to 0. We're gonna also return false, because basically these are invalid information, so invalid parameters, we don't want to process them. And lastly, because it passed through our check, sorry, not false, return not 0, return false. And lastly, because it passed all of our check, we need to actually pass it, so it's going to be DB service dot save items to shopping cart, and we're going to basically pass the product. And once we have done that, we're going to return true. So that's going to be our first implementation. Very simple, straight to the point, adding a product, do some minimal checks, and adding it to the database, in-memory database. So now what we're going to do is we're going to delete a product. It's going to be again public bool delete a product, and it's going to take type ID, a nullable int of type ID. Why am I saying a nullable int? Because as we said, we want to create a way that we're actually consuming the application. And when you think about it as a client, and sometimes a client, when they are trying to call an endpoint, they might forget to pass some certain parameter, and that will be null. So that's why we need to add this as a nullable int. So again, let's do the same checks. If ID equal null, we're gonna return false. If ID equal 0, we're gonna do the same thing, return false. And lastly, right now, because it passed the first couple of checks, we need to update it. So we're gonna say, for example, well, what was it? DB service dot remove from shopping cart, and we're just gonna pass the product ID. So because it's nullable, we need to convert it to int32. Let's do it like this. And once we have done that, let's return true. Okay, great. So these basically are the two methods that we want to currently test inside our functionalities for this shopping cart. So it's going to be adding a product and deleting a product. And for this shopping cart, what we did is we have injected the fake DB service to our class through constructor injection. So that's something that we really need to be careful about when we are trying to test it out. So that's first things first. So now that we have done that, now we're gonna go into our testing app.test, and there we're gonna basically add a new class which is gonna be solely responsible to testing the shopping cart. So here, let's see if this will work. Add a new class. We're gonna put shopping cart test. Okay, it added it here. Perfect. So what we're gonna be doing right now is we're gonna be starting adding the unit test, and we're gonna do the same thing as we done before. But as soon as we start adding it, you're gonna see that we're gonna be needing the DB service in order for us to actually initialize it, because as part of the 3 steps that we currently have, which is arrange, act, and assert, we need to, in order for us to arrange, we need to pass the DB service, and that's something that we're going to be doing manually. But the goal of this is we're going to be actually utilizing MOQ as well, and MOQ is going to help us remove the need for us to add it manually and actually directly utilize the MOQ library in order for us to inject DB service or fake and IDB service to utilize it. So let's try to do it first manually. So first, as we said, if we're gonna add a unit test, we need to add a fact. And basically, let's remove this. I don't know why it came like that. And what are we gonna call this test? And we're gonna just call it add product, and it's successful. That's gonna be the simple of it. And as we did before, we need to initialize it. So it's gonna be var shopping cart equal a new shopping cart. But here shopping cart is basically not happy. First, because we need to add the reference to it using testing app.functionality. The second here is if we hover over it, it's expecting, an IDB service interface to be injected to it, so it will actually work. So that's what we're going to be doing right now. We're going to initialize an IDB service manually, and then we're going to pass it here. So you might think to yourself, okay, how are we going to do this? It's very simple. So before this class here, we're going to add another class, and basically it's going to be public class, let's call it DB service MOQ, because we are trying to mock an actual DB service, and this is going to inherit from IDB service. So basically what we did is we created a class, and we have basically inherited from the interface that the shopping cart requires, which is IDB service. And for this to work, we need to implement the 2 methods. So implement interface, we have these 2 methods. Perfect. Now we need to actually do some functionality inside the IDB service so we can utilize it. So because we don't really want to have that, this is not nice. Okay, so let's try to add the functionality. First things first, it's gonna be property of bool, and we're gonna say process result. Why is that? So basically what we want to do is we want to actually create our DB service, and basically because we are mocking it, we want to, for example, tell the mock service what is the expected result that we want. So let's say we are adding a product and the expected result is true. We want to tell it that the expected result is true. So the way we do that is we create here a variable called process result, and based on that we can actually know the potential outcome or the actual outcome of our operation. So second thing is we need to property. What are we going to be adding to this service? It's going to require a product. So in order for us to verify which product is being processed by this service, we need to create a product, and we're going to call it product being processed. Again, this is all for demo purposes right now. This is not how we usually write it. The way we are doing it like this is for us to understand what is required for us to be able to mock an interface or to mock a library, and basically how mocking will actually work, and why do we need a library in order for us to make our life way more easier. So that's the second thing. The third thing is we need to have the ID for this. So public int, and we're gonna say product ID being processed. We're gonna make it get and a set, and that's nice. Okay, once we have done that, first thing first is here we need to actually start implementing the remove from item shopping cart and save to item shopping cart. So first things first, so let's start with the remove, and because we have said it here it's a nullable, we need to make it a nullable. And did we make it here nullable? Let me double check. Let's see. No, we didn't. Let's make it nullable. And let's make this nullable. And let's remove these. Don't really need it, because I forgot we did not make it nullable, which is a big thing. Okay, so let's go back here. And we made this nullable. Perfect, we made this nullable because it was. And now we need to implement the check. So if ID is not equal to null, we can actually process. And basically it's gonna be what we're gonna be saying to remove is we're gonna save the product being processed equal, actually product ID is just, we're gonna process the ID. Product ID being processed is equal to product ID, and okay, this needs to be product ID, not ID, excuse me. Okay, and let's convert this. So convert, excuse me, it's a bit late. Convert dot to int32. Let's do this right now. Let's pass this, let's put this here, and that should work. And we need to add using system because we didn't add it using system. Okay, great. So first thing first, we have done that. Once everything is processed, we're basically gonna return true. So we can put this like this. So if product, or we can do it like this. If product equal null, return false. Else it will return true. It will be processed and it will return true. Okay, nice. So that's the first functionality that we want to have. Let's fix this, make it look nicer. Okay, so this is the first functionality. The second one is going to be save. So the same thing that we did before is we need to check if it's null or not. So if prod equal null, we're gonna pass false. Return false. Perfect. Else, if it's not null, we're gonna add it. So we're gonna put product being processed, because we're just gonna make sure it's just being processed. We're gonna say equal prod and lastly we're gonna return true. So again, all of this mocking is we are just trying to mimic an action of a database, trying to save something, expected result, what's going on, how it's gonna work. It's just all trying to mimic a database. And this is trying to do all of the mocking manually. Again, when we introduce the library, everything is gonna be automated, but for now, it's gonna be all manual. Okay, once we have done that, now because we have created this class, DB MOQ service, if I copy this, what I can do here is I can, for example, create now and initialize it. We call DB MOQ equal a new DB MOQ service. And if I put here DB MOQ, now shopping cart should be happy because it's actually implementing the IDB service that we have, and we can see the red squiggle has disappeared. Great. So once we have done that, the next step for us right now is to actually start implementing the functionality that we want to do. So first thing first is, because the expected result is true, that I want to tell it what is the expected result, so it will so we can actually utilize it. So for the DB MOQ, we can actually pass the process result, we're gonna say equal true, because that's the expected result for us. Because if you see here, we have introduced process result, and the process result is a boolean, and basically this is the outcome of the process that we want to pass. So we're telling it that for this DB service, for the next method that we currently have, the process result that we are expecting from you is true. So you need to think about it that way. So once we have done that and we have created the shopping cart, now it's time for us to actually initialize the shopping cart. So what we're going to be doing is, let's create a new product. So var product equal new product, and we're going to just pass the int. It's going to be an ID, the name is going to be shoes, and the price is going to be 150. Okay. So that's going to be the product. Now we need to add it. So we're going to call the shopping cart dot add product, and it's going to take what? Product, correct. Great. Once we have done that, now we need to do the assertion. And basically what we need to do is we want to assert the result. So assert dot true, and basically in order for us to assert, what do we want to assert as a true? We want to assert the result. So here we need to var result equal, so the result of adding a product, we want to assert it's a true. And in order for the assert to work, we need to add this xUnit. So let us explain what happened here. First of all, we have added a shopping cart. And the shopping cart, for it to work, it needs to have an IDB service available to it, so it will mimic, because the IDB service mimic a database. So that's the first thing that we want to do. We initialize the shopping cart, and we initialize the DB service that the shopping cart utilize in order for it to, to fake communication with the database. But so how do we do that? In order for us to do that, and we have to mock it manually, we created a class which inherited from that interface. And once we have created the class, we want to actually mimic the functionality. So we want to, for example, set the return type, set the methods, set the object that's going to be processed, and basically the ID as well. So for these two methods, we have set the result, which is being the process result, if it's true or false, because here we wanted it true. So we set it to true, here. If, for example, we're expecting false, we should have this has been false. And then basically what we're doing is, once it has faked the process of that DB service mock, we're just asserting the results. If you have any questions, please feel free to put them in the comments down below, and I will explain them I will reply to you and explain it as best as I can. If not in the comments, in the next video. So once we have done that, the second step is we need to assert that the information is equal to what we have put it. So we're going to put assert dot equal, and we're going to put choose, and we're gonna assert the product, the dbMOQ dot product being processed dot name. So that's where we want to process. That's what we're trying to achieve. So because dbMOQ is actually representing a database in our case scenario, where it means that it's gonna go to the database, get the information of the product that we're trying to process, and then based on that name that we're doing, we wanna match it to this. And basically right now, because we don't have an actual database, what we did is we just set it up to this product being processed here, and we refer to it. So that's the first one. So let's save this, and let us save. Okay, it's saved, and now let's run the test. And now if everything goes to plan, we should see that test succeed. Perfect. So let's say we were expecting the result to be false and it's returning true. So let's see what's going to happen. So let's say I want to change the processed result to false, which is not the case because the expected result, as we have set here in the shopping cart, is true. So let's see what's going to happen to that. Save this, run this again. It should fail right now. Okay, so this needs to be here, excuse me. So that's the expected result, excuse me for this. So now let's run it again, and now it should failed. Okay, excuse me, it's a bit late at night, and I forgot to add the test. So the test needs to be assert dot equal. We need to realize the result with the expected result from the database. So it should be dbMOQ dot process result. So right now this should fail because we have specified that the process is false and the application and the shopping cart is gonna return true. So let's save this. So let's try to run this, and we should see here that this is gonna fail. We're gonna give us red that it has failed, because basically it gave us that one failed because this process result is giving us false, although the results that the add product is what's expected is true. So if we change this back to true and we save this and we run the .NET test, it should succeed right now because basically the expected result is true and we're getting back true. Perfect. So now once we have done that, the next step is we need to add more functionality, and basically the current functionality that we're going to be testing is the remove of a product. So we're going to be removing of the product, and it has to be successful as well. So before we do that, let's add the adding a product but failed. It's going to be similar to this. Let's try it out with a different reason for failure. So let's put fact. Let's delete this. Let's delete this. And let's start here. We're going to be utilizing this similar, so we don't have to rewrite it again. So let's copy paste this. And so this is going to be dbMOQ, new DB service. That's correct. The process result here is going to be false because it's going to fail. And basically what we're going to be calling it here is going to be add product, but it's going to be failure. We're going to put it due to invalid payload. That's going to be the case that we're going to test. So we have prepared it here. We're going to say that the process is going to fail. We have set it up, and now we have to actually execute it. So basically we're going to put var result equal shopping cart dot add product, and we're just going to pass null. And this should automatically give us a failure. And if we just assert the result, so this is going to be assert, and we're expecting false, so that's the expected value, and the result needs to be false. So that's the first test. Second test, assert dot equal, and this is going to be the result that we are expecting with the dbMOQ dot process result. So let's check this out. Let's run this. Perfect. Now we have 4 tests. Everything is passing as it should be. So the next test that we're going to be adding is related to the product. So let's add a fact. And we're going to be posting is removing a product. We're going to make it a success. And basically we're going to take the same thing. Copy this. No need to rewrite. And then we're going to make this result as true. And once we have done that is, let's take this as well. Where is it? Just take this, create a new product, add it. No need to retype everything. And basically, once we have done that, now we need to execute the functionality that it's actually removing. Because right now, don't forget, this is an in-memory database and every test runs separately. So right now, even though we have added a product here, by the time we run the second test, it's resetted. So we need to add a product first and then we need to remove it. So once we have added the product, now it's time to remove it. And basically what we're going to be doing is we're going to put var delete result equal shopping cart delete product, and it's going to be product.id. And once we have done that, now we need to assert the result. So assert true, because we're expecting a delete result true. And then we're gonna assert dot the equals of the delete result is equal to the dbmoq dot process result. Let's do this right now and let's run this. Perfect. Now we have 5 and all of them pass. And basically here we can see how we have utilized basically mocking in order for us to execute multiple tests on our functionality, and basically how we were able to fake an interface injection to our constructor for us to be able to utilize. And as you can see here, creating a mock class and adding all of this condition and making sure we are passing the right variable, and basically try to fake the entire journey. And this is a simple class or simple functionality shopping cart. Right now it only had 2 methods. So imagine if we had a class, for example, with 15 methods and everyone has a completely separate input and different configuration. It's gonna take a lot of time for us to try to mimic or basically mock the DB service manually. And once we have even mocked the DB service manually, we need to make sure that we have covered all of the different aspects. And this is very time consuming and very much error prone, because we're gonna make errors try to creating a mock library for testing. So for that reason, there's a lot of solutions out there, and basically one of the main solutions is to utilize a NuGet package called MOQ. And MOQ basically take care of all of this. So basically the mock library is basically we pass to it what interface we want to mock, and it will be responsible to create the fake instances, create all, for example, the process result, the object that we're passing, if there's an ID, the ID that we're utilizing, and all of that, and give it back to us. So first of all, it's going to remove the heavy load of creating a mock library from our side. It's going to make it more easier to mock very complex structure with multiple inheritance multiple dependency injection. As well, on top of all of that, it is much more stable than writing our own. So what we're going to be doing right now is we're going to be installing this mock library to our testing project, and then we're going to transform this code that we currently have to utilize that mock library. So let's get started. So first thing first, inside our terminal here, we're going to add a package. So it's going to be .NET add package, and it's going to be mock, as simple as that. Few seconds, and let's go here and we should see mock. Perfect. So once we have done that, my advice as well is to always update the .NET SDK here to 17. Sometimes it faces a lot of issues with .NET 6. So if you do this 17, and let's go back, sorry, not install it, to run it. So .NET test. We should see everything is still, but usually sometimes if you're having a lot of issues and it says it's not compatible, something like that, just make sure you update the Microsoft.NET Test SDK for .NET 6 to version 17. Just wanted to, I just saw that and I thought I reminded you of this. So once we have done that, let us now implement MOQ. So how are we going to be implementing MOQ? Let's go back to our shopping cart testing class. So we have all of this here. And this is all nice and hard work that we did, but we don't really need it. So what we can do is we can actually just do this and click the nice delete button. And once we have deleted this, we can see that all of this started to complain again. Oh, I don't have my mocking library. Why are you doing this to me? We're gonna fix it. So let's see how are we gonna fix it. So first thing first is inside here, let's create a generic mock library. How do we do that, you might ask? It's gonna be public, read only, and we're gonna basically do mock, pass it, it's gonna be shopping cart. We're gonna pass the sorry, not shopping cart, we're gonna pass the interface that we wanna mock, which is IDB service, and basically we're gonna give it a DB service mock, give it a name, and it's gonna be equal to new. And let's fix those references. So what happened here? So first of all is what we did is we initialized the mock library and we told it that what you need to do, let's go to terminal, and what you need to do is you need to create a full mock of the IDB service similar to what we have done before, and we have initialized it. That's all we did. We just specified put the mock keyword, we put the two brackets, and we said you need to mock this IDB service. And mock will gonna take care of everything for us. So now once we have done that, we don't really need this anymore because we have already defined the mock. See the number of lines that we're removing. And now what we need to do is, because it's requiring it, so instead of having db mock here, we're just gonna put db service mock dot object. And dot object means that we are initializing an object or a fake object or a mocked object of the IDB service. Everything is being done for us. No need for us to do it manually. All of this is being done by the mock library. So as soon as we put the DB service reference to the mocking library, as soon as we put that object, it's going to give a fake instance that we're actually going to be able to utilize in order for us to test. So that's the first thing. So once we have done that, the next step here is, instead of having this equal, what we're going to be doing right now is we need to actually have some logic here. Not a logic, we're going to, instead of having like a DB mock to process result, we're going to add the right terminology or right keyword for the DB service mock library in order for us to get there. So let's do this right now. So here for the result, actually let's remove this because we're going to be doing it with a second one. And actually let's remove this right now, and we're going to add a much more specific testing or assertion to do that. So it's going to be assert, or let's do it another way. Let's go DB service mock.verify. So this is something that the mock library will provide us, and basically we're going to be able to verify the results of our addition with the result that the shopping cart.add has executed. So we're going to create a lambda function, and it's telling us what method from the IDB service you want to verify, and we're telling it that we want to verify save item to shopping cart, and it's telling us, okay, what type of product will it take. We can pass a product, but we can tell it that you can expect any variable, because don't forget, save item to shopping cart, it expect a null or expect an object, so we need to pay attention to that. So how do we do that? We put something called it, and it basically hears. If we go to it, it says it. Let me see if I hover, it gives us some information. So basically, it allows us to have like a generic method of what do we want to have this parameter of this function is. So we're gonna put it dot is any, because any parameter will be accepted of type product. So it could be a product or it could be null. We don't really care, as long as we are covered by this. So once we have done that, we need to actually tell it what is the outcome that we are expecting. So on this outcome here, it needs to be let's do this right now first. So what happened here? So first of all, we have referenced the DB MOQ service library. We told it that you need to verify something for us, and we're telling it that you need to verify the save item for the shopping cart, telling it that your parameter that you are expecting could be anything of type product. So it could be an instance of a product, or it could be null. So that's why I put it, which refers to the collection of parameter that we can pass, is any. It could be like anything from for product, either a product or null. And we're telling it that you have only executed once, and that's why we did this right now. Right now, if also we want to verify the outcome of it, we can do this, but first let's actually execute this and make sure that excuse me, it's actually running as it should be. So let's save this and let's run this. Okay, as you can see, shopping cart still not happy. Oh, we need to update the rest. Let's update the rest and then we can execute. So we don't need this anymore. And instead of DB MOQ here, as we said before, it's gonna be DB service object. And then here, instead of mocking this, we can take this, and let's paste it here. And let's do this with the same here. Let's delete these, we don't need them. And we'll put here the DB service dot object, and let's do this right now like this. And we need to update this, because if this failed, we're basically what we are expecting here instead of, okay, so copy paste is always wrong, but what can we do? So right now here we just copy paste this, and here this is not right because this needs to be never. Yeah. Why is this never? Because if this failed, because here we are expecting a failure, add a product failure due to invalid payload, correct? And here we are passing a null, which is expected here, and we're expecting the results to be false. So the results needs to be false. It means that it did not execute, that it did not save anything to the database. And here that should be as it is. Let's save this. Let's run this again, .NET test. And we can see everything has passed. So let's do a recap here before we do a full summary. So what we did is we have, instead of mocking everything manually, we have utilized this mock NuGet. And basically what we did is we have initialized that NuGet package on top. This way we have initialized it, mock, and we specify which interface we want to initialize. And once we have done that, we refer to it here by once we do .object of that service, it's basically creating an instance of that object. And basically in order for us to assert the result or making sure the result works, we need to utilize the verify, or there's more than verify. Let's check this. So we can put, for example, db service.mock, and we can see that we can set up stuff, verify. So we have verify, which is what we're doing, verify.add, verify all, verify get, verify remove, verify set. All of these are built in. Right now we're just doing any generic verification for the sake of simplicity. And because this is the first step of the second step of the unit test. When further modules and much more advanced unit tests, we're going to delve into more complicated items. But for now, we just understand this. So we have verified it, that this needs to be run. And basically what we're verifying is how many times it should run. Because if it's run successfully, it means that it has run one time, and we're matching the execution time with how much time it has run. If it failed here, it means that it have not run, so basically the execution time is never, which is 0. And similarly to the success product here. So let's run this again, save, and let's run the test.NET test again, and we should see 5 out of 5 with everything green flying color. Perfect. So let's do now a quick summary. Okay, so now that we have covered mocking and we have covered the basics of unit test, our quick summary, basically, it's going to cover everything that we have learned today. So basically, the first thing that we have started is what is unit test, which is basically testing specific pieces of code. Then we said, why are we going to using it? We specified all of the benefits that comes with it. Then we have went into the framework. As we said, we can use any framework that you like, but I highly recommend xUnit. It's very fast, and it's very reliable, and very modern. And then on top of that, we have specified the ingredients that we needed, and then we have started building our application. So basically what we did is we have created a console application. We created some simple functionality inside our console application. Then once we have created that functionality, we have created a new testing library utilizing the xUnit. Once we have done that, we started with creating our first unit test. We decorated with the attribute fact, and then we have went through the 3 steps: arrange, act, and assert, the 3 A's. And basically the arrange mean that we are setting up our code in order for us to consume that part of code or functionality that we want. The act is basically executing it, and the arranged means that we are actually trying to the assert means that we are trying to compare the results and make sure that they are actually the outcome that we are expected. So once we have done all of that, from the simple functionality that we have added, the next step for us was actually to add a bit of a much more complicated functionality, which is going to be the interface injection to our application. So once we have actually injected the interface to our application, so for example, we have added a new functionality, and that functionality was called shopping cart. Inside the shopping cart functionality, the thing that we did is basically we have a fake IDB service, and that IDB service has been injected to our shopping cart through constructor injection. Once we have done that, we added some functionality here and there to our shopping cart. Once we have added that to our shopping cart, we created a new class inside our testing class library. Once we have added this inside our testing class library, we needed to actually write some unit tests. So again, we put the fact, we put the we have put the arrange, act, and assert. Once we have put the arrange, act, and assert there, we needed to, in order for us to arrange, we needed to actually initialize our shopping cart. But because the shopping cart has already been utilizing the IDB service as an injection for it, in order for us to avoid that work, actually not to avoid that work, in order for us to accomplish that work, what we needed to do is actually first to create a fake DB mock of our application, of our IDB service. So we created a class. That class inherited from the IDB service that we have created. We created all of the mocking that we needed manually there, and then we have injected it to our unit test. It's not the best way, but we did it in order for us to understand how mocking work. Once we have done that, we have added all of the rest of the unit test, and it worked as it should be. But then we saw the level of complexity that it has introduced. So after that, what we did is we have created the we have added the NuGet packages, which is called MOQ. Once we have added that NuGet packages, which is called MOQ, to our library, we have deleted all of the manual mocking that we have done, and basically we have utilized that MOQ library inside our unit test in order for us to actually execute this unit test utilizing the mocking library. And basically we have seen that the amount of code that we have removed and make it was a large amount of code, which made our unit test way smaller and much more impact and direct to the point. And we have saw there how we have actually utilized MOQ inside our unit test in order for us to execute those tests. So that was a quick summary of everything we have accomplished today. I hope this was a very helpful introduction to unit testing. There's gonna be a couple of videos after this going more in depth of how we can actually do more unit testing, covering different aspects of unit testing, calling a HTTP request inside our ASP.NET application, so on and so forth. Any questions, please write them down in the comment down below. As well, if you have any ideas or anything you'd like me to cover for unit testing, also please mention it in the comment down below. And I think if you made it this far inside this video, it means that you actually like this video. So please like, share, and subscribe if you like it. It will really help the channel. As well, type your favorite type of fruit inside the comments. That way I know that you have made it this far and you have watched the entire video. Thank you very much for watching, and have a good day.